You have about 40 seconds to finish up that check-in form and looking through the agenda. All right, that's time. If you didn't get enough time to fill out the check-in form, just make sure you fill it out as soon as you can, so I know that you guys understand the plan for this week. Let's take a look at the week at a glance together. There are a few things that I want to point out that are coming up or that we need to know. So at the very top here, shout out, majority of you completed your Delta Math assignment this last week, which is awesome. There are still some of you that didn't quite get there or are still struggling to get logged in. If that is the case, we need to get the ball rolling here, make sure that you guys are logged in and ready to go. If you are still having issues, you need to reach out to myself or Mrs. Lehman so we can help you, right? The second little reminder I have at the top is to pay attention to due dates. So this year, you guys have Tuesdays and Thursdays to work on all of your assignments. We did send out a reminder about our late work policy this last week, but it's really important, guys, that you complete the assignment within the time frame that we give you so you can stay up to date, okay? If we look through some of our due dates today, now last week you had started this SCIM kit practice. I believe it was on Thursday. Today it is due. So a lot of you have already finished it. That's awesome. If you didn't finish it, make sure you get it done by at least this evening. And then you're also going to have to mark it as done in Google Classroom. Remember, to get it done, you need to get to $100,000, sorry. And there are still power-ups. So if you're like, that is so much money, Ms. Carr, how am I ever going to get there? There are power-ups that you can get. All right, good to know, Jesse. Underneath that, we have a few things that are going to be due this week, but we'll get there when we get there. We are looking at quite a few learning targets this week. I'm actually pretty excited. We're going over literal equations and inequalities are our focus this week. And then, oh, I missed one of the reminders up here. Your PSAT is going to be on October 20th. Okay, now that seems a little bit far away, and we will have some more details as we get closer to that date. But yeah, be on the lookout. October 20th is the day that you're going to be taking it. All right, and then we come to today's agenda. So let's take a look there. We already completed that first bullet point, the check-in form. The next item on our agenda, we have some good news. Does anybody have any good news they want to share? Anything fun you did over the weekend?
Oh, Carolyn said she laughed a lot during the weekend, so it was a good, fun weekend.
Oh, good. I'm glad to hear that. Who else wants to share some? All right, quiet class this morning. We'll try good news again later this week, see if you guys want to share some then. But then that moves us to our third bullet point here, which is we are talking about 1.2.3 and 1.3.3 notes. So at this point, we're going to kind of split our separate ways, our in-person and our virtual people. In class, you're working with Mrs. Lehman today, and virtual, you are working with me. So bye, our in-class people. Oh, stop it, Grady. All right, so my virtual people, last week, you should have gotten a packet from Mrs. Lehman. She passed out a packet to anybody that was in class, and it had all of the notes for this week. So you're going to need to take about 30 seconds and pull out that packet. If for whatever reason you lost it, you misplaced it, or let's say you're 100% virtual, I did send out an email this weekend with all of the notes for this week. It's all the PDFs of that, so hopefully you were able to print them. At the very least, if you didn't get a hard copy, you can't print, then you need to go old school, grab out a piece of paper and a pencil, all right? So I'll give you guys about 30 seconds. If you could give me a thumbs up in the chat or a good in the chat when you are ready to go, that would be awesome. Thanks, Erica. And Alexis, thank you. I think it should just be like 3 papers again. So you have the 3 options, either the packet that Mrs. Lehman handed out to you, that hopefully you have, the printed packet or the printed notes that I emailed to you this weekend, or at the very least, you are just getting out a piece of paper and a pencil, going old school today. But you're going to want to get it down. There are some tricky examples that we're going to go through. Only have a couple thumbs. Make sure that you let me know when you are ready to go. Just throw it in the chat. Cool. All right, if you are still working on getting your stuff, we are just going to get started a little bit here. We're going to do a quick warm up. So you're still good to keep getting your materials. Just be listening. All right. If you want to, you can pull up our Jamboard link today. I am going to have it on the screen, though, so you can also just look at the meet. We are talking about literal equations. So to get started, I need a brave soul to read the I can statement for me.
I can solve a literal equation for a specified variable.
Thank you so much, Alexis. I appreciate that. Yeah, so last week and kind of the week before, we talked a lot about equations. Today, we're adding this word literal. Okay, and we'll talk about the difference between an equation and a literal equation in a moment here. To get us thinking, I'm going to give you guys about a minute to go through. This is kind of one of those logic puzzles. I want you to decide what, and don't type it in the chat yet. I'll ask for answers and I'll call on some people, but I want to know what the value of each of those objects would be. So like what an apple would be, what a banana would be, what a coconut would be, and then what this final answer would be here too. So I'll give you about a minute. Make sure that we are using the chat appropriately. Remember, this is just to communicate with me and the rest of your class about the math that we're going over, all right? So I'll give you guys about a minute to go through both of those. All right, do I have a volunteer for that first one? The one on the left with the apples and bananas. Awesome. Thank you so much, Jesse. Let's hear it. What'd you get? You got 16. Do you want to turn on your mic and explain to me how you got that?
Well, I saw that the apples, there's 3 of them, so that's 10, 20, 30, so that has to equal, so the apples are 10, so, and then the apples, so that's 10, and then I thought there's 2 bananas, so that has to be 4, because 4 plus 4 equals 8, and then 4 minus 2, so 4, and then I would assume this is, a 2, because the answer is a positive 2, so it's got to be 2 plus 10 plus 4 equals 16.
Beautifully said, Jesse. Thank you. So we get 16 as our final answer, and Jesse really broke that down awesome for us. Let's hear from somebody else. Amani, why don't you try the second one? What do we think?
I honestly don't know.
Well, let's break it down. Let's
Wait,
look at this. Let's look at
okay.
the first one. If 3 of our flowers are going to be 60, think about that. How could I figure out what each flower would be worth?
Is it 15?
You're very close. It's actually going to be 20. So the way I did that, Amani, I did 60 and I divided by 3 to get that even number. Does that make sense?
No.
So since there's 3 flowers and they're all the same, we had to do 60 divided by 3 because they're even. We're evenly distributing those values and we get 20. Right?
Okay.
If they were different things, we wouldn't be able to divide evenly, but because they're all the same picture, we can divide and get that value. That's the same for all of them. Right?
Okay.
Thank you for trying that. So if we know that our flower is 20, let's hear from somebody else. If our flower is 20, Erica, what do you think the blue flowers are going to be then? Each of them is going to be 10? Hold on. If both of these were 10 and I added 20. What? Ah, we fixed it. Okay, good. Good catch. So yes, each of our blue flowers is going to be 5. If we know this is 5, then we can say our yellow flowers are 2. So all together, we got 2, 20, and 5. What's our final answer here, people? You can type it in the chat. We're doing this last line. What would our final answer be? I labeled all the numbers for you. What do we think? Oh, you were so close, Jesse. Remember, PEMDAS, we are going to do multiplication or division first. So we're going to multiply this. 20 times 5 gives me 100. And then we add the 2. So it's 102. I think you added before you multiplied. There you go. You fixed it. All right. Thank you, guys. So what this was kind of like our pretty version of what a literal equation is, where everything is unknown. Okay, so if you're on the Jamboard, we're going to that next one. Let's talk about it. What is a literal equation? A literal equation is where multiple variables are used. Okay, so you're going to have equations where it's only letters, it's only variables. right? We're not going to get a one number answer here when we're solving. We're going to get lots of letters or lots of variables as our solution, okay? So to solve these, you're going to work your way, instead of PEMDAS, and we kind of talked about this last week, instead of PEMDAS, we're using SADMAP. So we're going to undo addition and subtraction first. Okay. Followed by multiplication and division. I'm going to abbreviate. You guys know what I'm saying. Then followed by exponents. And finally by parentheses. And remember, we said this is where we're calling SADMAP, which is just PEMDAS backwards. So we're gonna do these first, followed by these, and lastly, we have exponents and then parentheses. Give me a thumbs up in the chat when you are good to go. Give me a thumbs up or a good in the chat when you have filled in your blanks, you have written this down. You're ready to go on to the next slide. All right, now as a reminder, if you do miss something, this will be posted at the end of the day. So if you miss something, it's not the end of the world. Just check back later this afternoon and I will have this filled in for you guys. All right, we are gonna move on to that next one. If you're on the Jamboard, just click the next button with me. So here we go, we're gonna actually go through and solve a literal equation. Before we do, I want to throw a little reminder at you. It says, remember, anything that touches the variable will be the last thing that you get rid of. So anything that is directly next to what you're solving for, that's going to be the very last thing that you move. Our goal is to get one of the variables, one of the specified variables, isolated or all by itself. But before we do that, this question kind of has two parts. First part, we're choosing the correct equation. Second part, then we're going to solve. So here we go. Distance is equal to an object's rate multiplied by time. Identify the correct literal equation, then solve for t. So out of A, B, or C, we're choosing our correct equation. Now, if we remember from last week, we can use some of our annotation skills. Looking at that first sentence, what are some of our operation words? Some of our math words. There's only two of them. What's one of our math words? Type it in the chat when you know it. Jacqueline, what do you think one of our math words is? Oh, thank you. Alexa said multiplied. Yep. I'm gonna underline that and put a dot. Jacqueline, what do you think the other one is? All right. Equal is our other one. And then we actually have three unknowns. Distance, we don't know. I'm going to assign that D. Rate, we don't know either. I'm going to assign that the variable R. Yeah, thank you, Jacqueline. And the last one, T for time. And if we annotate, now you can see where that annotation is really going to help you out, because now it's shown us the answer. So out of A, B, or C, guys, what's our correct equation here? Ooh, you're close. Yeah, there you go. Now we got the answers flooding in. C is our correct answer. You'll notice that when I annotated, I put the dot in the middle, but remember that if two things are right next to each other, that also means multiplication. So now I'm going to rewrite this, and it tells me that I need to solve for T. That's my goal here. That means I need to get everything away from T. T should be the only thing left on that side. So I'm going to draw my line through my equal sign like I do every other time. And then I'm going to work my way through StatMap. So from our last slide, the first thing we're looking at is to see if there's anything that's being added or subtracted to T. Well, if we look, there are no plus or minus signs, so I know automatically that we're not dealing with addition or subtraction. However, in that next step, between division and multiplication, if we look at T, right now R and T, like I said, are right next to each other, and that indicates multiplication. So how do we undo multiplication, you guys? What's our inverse of multiplication? Yeah, thank you, Amani. Division. So to get T by itself, I'm going to divide by R. And now I can cross off my R's. And now I have T equals. Now here's where it gets a little bit weird. We always want to ask ourselves, are these like terms? So remember, like terms mean the same variable. If I look, D and R, those are the two that I want to ask myself about. Those aren't the same letter, meaning that they aren't like terms, meaning that I can't combine them. So what I'm going to do, if they're not like terms, you literally just leave them alone. They stay like that. That whole thing is your final answer. How we feeling? Thumbs up, thumbs down. Give me a good or bad. Okay, I got some thumbs up, some thumbs down. That's okay. I want you guys to try out the next one. Now, remember, if you get it wrong, it is not the end of the world. Okay, don't let it ruin your day. I want you to try for me. It says, the following equation is used for relating the faces, F, edges, E, and vertices, V, of 3D figures. Solve the equation to find the number of faces a polygon would have. So what I need you to do, or you to try to do, is to solve for F. That's what you're trying to solve for here. Okay, so I'm going to give you guys about 45 seconds to try and go through and solve for F. Move everything else away from F. Think about our inverse operations. And we're using StatMap. All right, Erica, what did you do first? to try and solve for f?
Wait, sorry, I wasn't. Can you repeat the question?
I wondered what you would do first if you wanted to solve for f, if you wanted to get f all by itself.
You take you add e on both sides and then you subtract v.
Beautifully said. Thank you so much. So I'm going to add e on both sides. Now I can cross off my e's. And now I'm going to bring down what I have left on the left side. I still have the f and the plus v. Now we're going to ask ourselves, and I'm asking you guys, so you're going to give me a yes or no in the chat or say it. Are 2 and e like terms? Give me a yes or no in the chat. Are 2 and e like terms? What do we think? Jesse, why do you think yes?
Because there's an invisible 1 in front of the E.
Oh, say that a little bit louder. You're very quiet.
There's an invisible 1 in front of the E.
Oh, so there is a number in front of the E. You're absolutely correct. However, remember that for like terms, we don't care about the numbers necessarily. We care about the variables. So we have the letter E here. Since there is no letter here, they're actually not like terms. I like that you thought about the invisible 1, though. I do like that. Okay, if they're not like terms, here's the deal. You just write them right next to each other. So you're literally just going to write 2 plus e. We leave them separate. You don't combine them. Right? Then, like Erica said, our next step, we're trying to get f all by itself. We're going to subtract v. And now we can cross off our inverses. And I still have the f over here. And again, we're asking ourselves, are these like terms? Do they have the same variables? Well, 2, e, and v, I don't see repeats of the same letters at all in there. So again, if they're not like terms, we're not combining them. We're literally just going to write them right next to each other and keep them separate. So I'm going to keep it 2 plus e minus v. And that's our final answer. As soon as you get what you were solving for all by itself, you're done. What questions do we have so far? You guys are doing great. I want you to know that this is a trickier subject. So if you're still a little bit confused, that's totally all right. We're going to go through another example or two, so don't feel too stressed out. All right, let's go through this next example. Again, you should be following along on your packet. If for whatever reason you misplaced your packet, you're writing on a separate sheet of paper. Okay, this one it says, to find the perimeter of a rectangle, you must calculate the sum of twice the length and twice the width of the rectangle's sides. Solve the literal equation below to find the width of the rectangle. Okay, so here I've given you the equation. You may need to, in an assessment, choose the correct equation like we did in example 1, but I really think that we need to focus on solving these. So I've given you the equation. We have twice the length and the sum of twice the width. If we look at this last sentence, it's telling us what to solve for. What do you think? It says solve the literal equation below to find the width of the rectangle. So what variable do I need to solve for here? If I want to know the width, what variable am I solving for? Alexis, what do you think? If I want to know the width, what variable am I solving for?
The P?
Ooh, do you think P stands for width?
Oh no, the W.
Yeah, there we go. Much better. So we want to isolate W. That's our goal. That means we need to move everything else away from the W. We want W all by itself. So again, I'm doing STADMAP. And we're going to start with subtraction and addition. So if we look, I want to know, is there anything being added or subtracted to the term with the W? Now in my equation, on the side with the W, I have 2L plus. Guess what? That means that they are adding 2L. So to undo that, we're going to subtract the whole thing. You're going to subtract 2L on both sides. And then you can cross off those inverses on the right side, the opposites. Are P and 2L like terms? Yes or no? Are P and 2L like terms? Yeah, thank you, Jesse. They are not. So we are going to write them right next to each other. You don't combine them. And then on this side, we still have the 2W. I like your honesty, Jacqueline. Maybe. So now we still have one more thing to do. We did our addition and subtraction. Now we're moving on to division or multiplication. And this is where, if we remember from our first slide, I said the thing right next to the variable we're solving for is going to be the last thing we get rid of. Guess what? That is so true here. The last thing we're getting rid of is this 2 because it is right next to the variable. And again, we remember that being right next to each other means multiplication. To undo that, we are going to divide. Now, here's where it's a little bit weird. When you divide on one side, you have to divide the whole thing on the other side by 2 as well, the whole thing. So if you divide one term, you have to divide all of the terms. Now we can cross off our 2's, and literally your question, literally equations, your answer is going to be this whole nasty fraction looking thing. You're not going to get a number answer. Right, now that we went through another example or two, oh, actually, there's one more I want to go. As I said, you guys, your PSAT is coming up in not too long. So here is an SAT style question. This is literally taken from a past SAT, okay? And this is totally doable with what we've covered today. So this is the type of thing that you might see on your PSAT on October 20th, and it's multiple choice. It just wanted you to choose the correct answer out of A, B, C, or D. I'll read it for you. It says, at a store, a coat originally priced at P dollars is on sale for T dollars, and the relationship between P and T is represented by 0.8 P equals T. So this is our equation that they give us. I want to know what is P in terms of T. Okay, so I'll give you a moment to brainstorm. You are thinking, would I choose A, B, C, or D if I want to solve for P, and that is my equation? No, we don't have half days this year, Jesse. Marcus, what do you think? Would you choose A, B, C, or D if we were solving for P? What would your answer be here?
A.
A, why'd you choose A?
Well, because the T's alone in the problem, and That's about it. I don't.
That's okay. Let's talk it through, Marcus. So you are trying to solve for P, right? That's what we want to get all by itself. Right now, we have the 0.8 and the P right next to each other. How do you undo that? Remember, if they're right next to each other, they're being multiplied. How would I undo that, Marcus?
Division?
Division. So we're not subtracting. A isn't going to make sense because that would be subtracting 0.8. We want to divide 0.8. So which one would be our correct answer here then, you think? If we're dividing.
B.
B? Did we divide in B?
Oh, no. I meant C.
You're so close. Jesse got it. It is D because C and D are tricky. C, we're dividing by T. You still have that division sign, but D was the right one because we needed to divide by 0.8 on both sides. Does that make sense, Marcus?
Yeah.
Okay, cool. Oh, I thought you typed D's too. Yeah, Erica got it. Oops. All right. What questions do we have at this point? Don't be shy. This is a tricky subject. Grady, do you want to elaborate on that? What's your question? All right, well, Grady is thinking of his question. The rest of you that responded said you're feeling pretty good. Oh, Grady, we're just confused. We probably just need more practice. That's okay. Like I said, this is a tricky one. It does take some practice to really get the hang of it. So that being said, I want everybody to try number 1 for me. Just try it on your piece of paper. You are solving for M. Okay, look at number 1. You're solving for M in that equation. I need to get M all by itself. If you think of a more specific question, Grady, I'd be more than happy to answer it for you. If not, my suggestion is to just keep practicing. Okay, so we're all looking at that number 1, and you are solving for M. Remember to use your SAD map or PEMDAS backwards. All right, who thinks they know how to do it? Talk me through it. I need a brave soul to try and talk me through it. Man, we are quiet this morning. All right, then I'm going to pick on one of you. Kaden, what do you think my first step would be, Kaden? If I want to get M all by itself and we're using SAD map.
If you want to get M by itself,
Mm-hmm. What do we think?
Shoot.
Work your way through SADMAP. So think about if there's anything being added or subtracted to M first.
Yeah, there's multiplication to it.
There is? Yep. But
So we
before
can do division.
I will do division, absolutely. Before I get there, though, do you see anything being added or subtracted on that side?
Yeah, B.
Yeah, so what are we going to do to undo that?
Subtract.
Yeah, good job, Kaden. So we're going to minus B on both sides. Cross this off. And then because Y and B are not the same variable, they're not like terms, I'm just going to leave them right next to each other. And the MX comes down. And then like Kaden said, we're trying to get M by itself. And right now he said that M and X were being multiplied. So to undo that, we're going to have to do division. So we're going to divide this by X. Remember, when we divide the whole thing by X. Okay. So our final answer here, we would have Y minus B all over X equals M. As soon as you get that variable by itself, you're done. All right, I'm going to do one last example, and then we'll call it good on examples today. The reason I'm doing this one is this one's a little bit different than our past ones. So here I want to solve for Y. This is what I'm trying to get by itself. And normally we would get rid of anything that's being added or subtracted first. So our gut goes to the plus X. However, because this is kind of in this like big fraction, there are actually invisible parentheses here. So what that tells me is that I would do that last. I wouldn't touch anything in that top, the numerator, until the end. Instead, I'm going to get rid of this denominator. So to undo this division by Z, we are going to multiply by Z on both sides. And then the Z's go away, and I still have X plus Y equals 4 times Z, or you can just write 4Z. Who knows my last step if I need to get Y all alone? My very last step here.
Get rid of the X.
Yeah, how would I do that, Marcus?
Subtract it.
Absolutely, good job, sir. So now I have Y equals 4Z minus, oh, I forgot the minus sign, minus X. And since Y is all alone, we did it, we're done. That's it. Right? Questions? Now, if you did the challenge problems, come back at the end of the day. I'm going to have the key to those posted in the Jamboard so you can click on those and see how you did. What I need from you guys for the remainder of class, so there are 2 items that I want you to do. Yeah, you know I love my memes. There are 2 items that I need you to do. First, I need you to complete the exit ticket. So if you go back to the week at a glance, which I see a lot of you are on, there is a link here that says exit ticket. If you click on that, it's going to bring up something that looks like this. And all it is, it's asking you how you feel about today's lesson, if you want to see some more examples, and then it asks you 1 question over the material. And it's just so I can get an idea of how you felt about today and whether or not we need to go over it a little bit more. So fill out the exit ticket for me. That's the first thing. The second thing, and this is where you can kind of choose. Tomorrow, you're going to have 2 things to try and accomplish during your virtual learning day. You're going to have the 1.3.3 practice, which is the practice over what we just did. And you're also going to have Delta Math. So I will give you the option with the remainder of class. You can choose to get a head start on the practice or on the Delta Math. Both are linked again in the week at a glance. Right? So exit ticket and then take your pick between the 2. Are there any questions about what you are supposed to be doing before I let you guys go? You say nope. All right, then I will let you guys head out. Have a wonderful rest of your Monday. Bye, everybody.